Appendix A, Chains and Cassettes. Let me just take a minute of your time to review some fundamentals of chains and cassettes. Here we have an 8-speed cassette, a 9-speed cassette, and a 10-speed cassette. Here we see them side by side with a level across the top, and note the location of the bubble in the level. In each case, the small cog is touching the level. This means that all three of those cassettes have the same stack height. And it also means that as we go from an 8-speed to a 9-speed to a 10-speed cassette, that the cogs have to become closer together. Evidence of the cogs being closer together can also be found by just looking at the spacers between the cogs. Here we see on the left a 9-speed spacer, 2.53 millimeters thick, and on the right a 10-speed spacer, 2.33 millimeters thick. Because these cassettes all have the same stack height, they will all fit equally well on a 10-speed freehub body. But the 11-speed cassette that we see here has a taller stack height, so it will not fit on a 10-speed freehub body. More about 11-speed cassettes in a few minutes. Now, as amazingly strong as chains are, they only are made up of 4 parts. We have outer plates, inner plates, bushings, and pins or rivets. The width of the chain is often expressed in terms of the length of the rivet. Here we see the parts of a disassembled chain, the outer plates, that's an inner plate, that's another inner plate, that's a bushing, there's a bushing up on its side, and there's a pin. Note that that part of the inner plate fits into the bushing. Because the cogs in the cassette become closer together with increasing numbers of cogs, we have increasingly narrow chains. There's an 8-speed, a 9-speed, and a 10-speed. One thing that does not vary, though, is what's called the chain pitch. In all three of these chains, the rivet to rivet distance, or the chain pitch, is a constant 1/2 inch. That 1/2 inch chain pitch is exactly what's needed to fit between the teeth of the cassette or chain ring. But the outside width does change. Here's an 8-speed chain, nominally 7.04 millimeters thick. A 9-speed chain, nominally 6.72 millimeters. And a 10-speed, 5.96. Different brands of chain could vary a few hundredths of a millimeter from these dimensions, but that's not significant. Continuing that trend, we find that the 11-speed chain at 5.61 millimeters is even narrower. These are 2 Shimano Hyperglide pins. Using the right kind of a chain tool, the pilot helps guide the rivet into position. You can see that the rivet part of the 10-speed Hyperglide pin is shorter than the rivet part of the 9-speed pin. The 9-speed pin would be used to connect 2 ends of a 9-speed chain, and the 10-speed pin would connect 2 ends of a 10-speed chain. Even though the outer dimension or width of the chain is decreasing, going from 8 to 9 to 10, amazingly we see that this distance between the inner plates is a pretty much constant 3/32 of an inch. Here's a nice Shimano 105 rear hub, and I put on it a 10-speed cassette. Here we see a 10-speed chain on the 3rd cog. Note that there's a little bit of daylight between the chain and the 4th cog, and also on the other side between the chain and the 2nd cog. With the 9-speed chain, the daylight is either gone totally or reduced, increasing the chances that the chain could sometimes catch on one of the neighboring cogs. With the 8-speed chain, the problem is even worse. In fact, the 8-speed chain won't even fit between the 2nd and 4th cogs. Here's our 11-speed cassette again. Even though the stack height of this is higher, the cogs in the cassette are still even closer together than they are with a 10-speed. Proof that the cogs are closer together is given by the thinness of the spacers. So you need the narrowest of all chains to fit between the cogs. Just to summarize this, we'll make a little table with 3 columns: chain and cassette speed, width of spacers between cogs, which of course measures how close the cogs are together, and then the width of the appropriate chain. All of these in millimeters. As the cassette goes from 8 to 9 to 10 to 11 cogs, we need a comparable chain because the cogs are closer together, and we see that by the narrowness of the spacers, and we of course need a therefore increasingly narrow chain.